This is problem 4, 151. We're supposed to replace the loading by a single resultant force and specify the location of the force measured from point 0. So I'm just going to draw this out again. Let's see. Oh, what I did there. Okay. And draw it out again. And we have this point O on the right. We have that 500 kilonewton times meters moment on there. And then we have, I want to replace this part A, so that triangle to the left, with a single force. We'll call that FA. And then we'll replace part B with a single force. And then we have that 15 kilonewton force. We can figure out the distances really quick. So the distance to FA is going to be 2/3 of that 7.5 meters, so that'll be 5 meters. And then we know the distance to the edge of those triangles was that 7.5 meters. And then we know that distance to the force, or FB, is just going to be 1/3 of that 4.5 meters. So that'll be to here, that'll be 1.5 meters. And then the distance all the way over to the 15 kilonewtons is just that full distance, which is 7.5 plus 4.5. So that would be 12 meters. So there we've got all the forces now. To figure out the resultant force, we just know that the resultant force is going to equal the sum of all of the forces. And so the resultant force is going to equal that FA plus FB plus 15 kilonewtons. So we need those FA and FB. FA is just going to be 1/2, because this is a triangle, so we're trying to find that area underneath that triangle. 1/2 times 6 kilonewtons per meter times 7.5 meters. And then for FB, it's also a triangle, so it's 1/2 of that 6 kilonewtons per meter. I don't know why my pen's not working. Times 4.5 meters. Let's spread out over that. And then plus that 15 kilonewtons. So I'm going to calculate that out. Let's see, so that's 1/2 of 6 is 3 times 7.5. So it's 22.5 is what that FA equals, plus 1/2 times 6 times 4.5. That'd be 13.5 kilonewtons, because those meters are just canceling out, so meters cancel out, and plus 15 kilonewtons. So that gives us 22.5 plus 13.5 plus 15. So that gives us FR equals 51 kilonewtons. So that's part of what they asked for, was the resultant force. The other part that they asked for was the distance that'll be. So in order to do that, I'm just going to scooch over here to do it. We're going to do the sum of the moments about point O is going to equal that resultant force times that distance. So the sum of the moments about O, and let's make just end of the board is positive. So that we have to remember that 500 kilonewtons times meters. So that moment over here. Then what the moment that FA makes, so that's going to be plus FA, which, let's see, I'm going to write it right here. This one was FA, this was FB, and that's the 15 kilonewton ones. So 22.5 kilonewtons times that distance, that 5 meters, and then plus FB is that 13.5. and that's times that 7.5 plus 1.5, so that distance. So that would be, what, 9 meters? Yeah, 9 meters. And then plus, because these are all into the board, 15 kilonewtons times that full length, which would be 12 meters. And that's going to equal that resultant force, which was 51 kilonewtons, times that distance. And that distance is what we're interested in finding. So now we just need to add everything up, divide it by the 51 kilonewtons to get our distance. So I'm going to do that on the calculator. So I get the distance equals to 17.9 meters. So now we've checked back with the find statement. This is they want us to replace the loading by FR and FD. So we got D and we got